Hello, my name is Jimmy and this is the sixth lesson in the Neo Blockchain course. In this tutorial, we will get to know the Neon.js JavaScript library and develop our first decentralized application using this library. What is dApp? Imagine a classic web application. It consists of a front end and a back end. If the back end of such application is represented by a smart contract, so it's located in a decentralized network, an application is called decentralized or dApp. Neon.js is a JavaScript library for interacting with the Neo blockchain. It allows you to quickly and easily send RPC calls, create transactions, and call smart contracts. Okay, let's check this library out. A link to the Neon.js library GitHub will be in the description. Instructions for installing and connecting the library to our project can be found at this link. The documentation can be found here. Also in this document, there is an overview of the library, its functions, usage, and how to install it. The documentation describes how to implement the library by using the npm package manager. But in our lesson, we will use Yarn and import the library into the project or use the tag script. Let's start developing our dApp. As I said, it consists of a smart contract and front end. Now let's start with the front end. We will React JavaScript framework for front-end development. If you are not familiar with it, you can use any other framework or use simple JavaScript. Let's create a project template using the create-react.app utility and enter the name of our project. The utility unpacks the project, downloads the dependencies from the network. This will take some time, so let's start writing a smart contract. For example, we will develop a smart contract that multiplies two numbers, a simple calculator. We will use Python to develop this smart contract. At first, we create the main function. It will take two parameters, operation, which will include only the operation multiplication, mul, and args, arguments. Arguments will include an array in which there will be two numbers that we will multiply. Next, we will add an operation check. For the mul operation, we will have to get the multiplication of number in the array. Otherwise, we should get 0. Save changes. Move our contract to the directory with NeoPython. Compile the contract and deploy to the network. We will use NeoLocal. NeoLocal is a NeoPython connected to the private network. NeoPython is already launched. Let's open a wallet. Enter the password. And then we will see the help to find out how we can compile and deploy the contract. To do this, use schelp command. We need an scbuild command to compile a contract into an AWM file without deploying it to the network. If we decide to immediately deploy it, this can be done using the build run command. We run the scbuild command and see that this command accepts the path parameter where the contract file is located. After successful compilation, we see this message. If the file was not found, then we would not see such a message. Now, let's deploy our contract using the scdeploy help command. Now, as we can see, the command takes many parameters. The first parameter is the path to our AWM file that was just created as a result of compilation. Next, we should indicate whether the contract stores information or not. In our case, the contract does not store anything, but only calculate and immediately returns the result. That's why we set false. Next, we check whether our contract uses dynamic calls or not. Since it does not use them, we also set false. Our contract does not accept any funds, so set false again. Next, we set the types of parameters that the smart contract accepts. Parameter types can be viewed in GitHub City of Xeon. Our contract accepts operations. It's specified in parameter types as 0, 7. It also takes an array, which is indicated by number 10. After that, we specify the return values. In our case, it's an integer value, parameter type 02. Enter the password and wait for the deployment. After successful deployment, we will see the success message. Next, we need the information from the hash field. This is the hash script from the smart contract by which we can access our contract. Our unpacking of the React project template is completed. Now let's go to the directory with this project and add the Neon.js library to our project. To do this, we use the Yarn package manager. While the library is being added, let's run our project in the IDE. We will use WebStorm. Open our project and immediately start it with the yarn start command, or npm run start if you use npm package manager. Remove all unnecessary things that we do not need in our project, for example, CSS and tests. Also, do not forget to delete links to these deleted files. Refresh the page and we can see that we received a hello message. This means that everything started correctly and we can continue to write our dApp. Let's transform the function into a React component so that it can be able to store the state of our fields. We will have two fields, A and B. we will multiply these two numbers and output the result. When using fields, we need to store their value, and for this we will use state. We have declared the state function. As I said, our state will contain three fields: A, first number, B, second number, and the result. By default, their value will be 0. Also, declare a render function that will be called when rendering our component. Render will output hello world. Remove the extra function because instead we use the React component. Save and update the page. Hello world is disabled on the page, which means that everything started correctly and we can continue. Now create a form in which we will enter the data. To do this, add the tag form and two tags input. We add the tag type number because we will only enter numbers in it. No strings interest us. In name and value, we specify A to get information from the A state. In the next input, we will specify B. We also need to add an event handler to change the value of this onChange field. This function will be called when the value field changes. In the second input, you also need to add handler for this event. Now insert the separator and see what happens. Now we see the fields, but we can't change them. This is because the onChange function is declared, but it does nothing. Let's add a state change to it. Now check. As we see, the fields are changing. That's what is happening here. Using the onChange function, we change the state. We extract the name attribute from the input, change the state by the A attribute, and insert the value in the value field. It turns out that our field value changes and it's written to state. Add the output to the result and the button by which we will perform the calculation. Add a button and call it calculate. Add a separator and a field with the result of our calculations. We refresh the page and see that the button and an information output field have been added. If you press the button now, only the page will be updated and the form will be sent since 0 values are entered in the fields. We do not need to submit a form, so let's make an event handler when submitting the form. Add to prevent default statement. It allows me to submit a form and not reload the page. Let's add additional information to understand which field we are responsible for. We have added information and now it's clear which field is responsible for what. When we try to multiply values, nothing happens except for the output of hello to the console. Now let's call the smart contract. For this, we will first connect our Neon.js library. You can find out how to do this in more details in the documentation. We can use import Neon from City of Zion, Neon.js. Let's check the documentation. We see that it says the same thing. Let's call our smart contract. The documentation also says how to do it. For a usual call, we need to run a Neon create script. Pass the script hash that I demonstrated earlier after deploying the contract. Also, pass operation mul and arguments a, b. Let's try to do the same. Create a variable, script neon create script, and pass parameters to it. Script hash. Be sure to remove 0x from the beginning of the hash. The next parameter is an operation. Enter mul and arguments. Here we will pass an array of 2 arguments, a and b. Now let's call our script. To do this, run rpc query invoke script. Since rpc is not declared anywhere, you need to get rpc from the library. Next, we pass the script function and execute it using the execute command. In this command, we must specify the URL of the node to which we connect to call the script. We will connect to our private node. Now we develop the action that should be performed after successful or unsuccessful call. In our case, we simply display the message in the console. Let's see the result. Fill in the field and press the button. We see that the function num2hex string should take a number, but it takes a string. The fact is that input stores the value parameter as a string, but we need a number. To do this, we will convert this value to a number and try again. Enter the value in the fields and click the calculate button. We see that the request is gone. It has an ID and a result. The result is successful and it stores a stake. So that is what remains at the top after calling the contract. In stake, we see an element of type integer with a value of 6. This is the result of our calculations. Now let's take this value and print it to results. To do this, instead of a usual output in a console, take a value of the result and write it to state. Now let's refresh the page and check how it works. As you can see, the results are correct. In this lesson, we learned how to create simple dApps. To create more complex applications, you need to study the documentation and try to create something of your own. This concludes our lesson today. Thank you for attention and see you in the next lesson.